Ladies and gentlemen, good evening. Let's get started with Yolo. You only look once. This is an awesome image segmentation and object detection library and framework for Python, and you can actually there's actually also a client, so you can just go and write commands in the terminal. If you don't want to use Python, then that is actually totally doable. But I'm going to focus on the Python library in this video right here. So first of all, it is located at ultralytics.com, and there you can get a lot of good documentation and easy ways to actually get started. They have an open source way, which is free, and you can also, if you want to use it for home projects or non-commercial projects, then it's free. If you want to use it commercially, and if you don't want to share your models that you're training, then you have to pay for it, and you have to contact the people behind Ultralytics, and then they will tell you a price. But if you want to share whatever you're doing, then it should be free. And if it's for non-commercial purposes, then it's also free. But let us just get right into it. What is it and what does it do? So the difference between object classification, I made some other TensorFlow videos where you saw that we could create we created some layers. So we created a model where we had some layers in it, and then let me just go to. I just want a whiteboard right there. So I wanted my whiteboard right here. So the issue is that we have some kind of image right here, and usually there are a lot of things are going on in the image. We have maybe here we have a dog. So of course this does not look like a dog, but here we have a dog, and then we have a cat over here, and then we have the owner, and then we have the owner down here. What the problem we want to solve is we actually want a library that can actually fetch the locations inside the image for each of these objects right here, and they can give it the right label. So we want the right category, and we also want the position inside the image, and that is exactly what the Yolo library does. And it has been underway for like this is 10 or 15 years. But right now it is just getting better and better and faster for each release that are released. So yeah. And the way to do this is that you can use your CPU, or you can use your GPU, your graphical processing unit, or you can use your regular CPU, your regular computing processing unit instead. And of course, it's much more efficient if you use your GPU. It's much faster than the CPU. And also, if you can scale down your images that you're looking at, then of course it's also much faster than if you're using high resolution images where you want to have object detection and that. I've just turned on the object detection just before I started this video right here, and you can see this is what it looks like if you use the default. I don't look that happy. It's because I had to. It took me some attempts before I could actually get this detection right here. And here you can see we have a person that is located right there in that box. Then we have a cup in the other box, and then we have a cell phone. Of course, it's actually not a cell phone; it's a remote control. I can say that, but there are some built-in. There are some just off-the-shelf models that are just ready to take in use, and you can do that. And and this is one of the off-the-shelf models that I'm using right here. If you have some other purpose and you want to scan for objects that are not inside I think there are 50 categories per default in the model that I took right there, then you can just train. You can train this Yolo. You can train this library quite easily actually. And what you get here is actually you get all of the layers. You don't have to sit and specify each layer in your in your image detection, in your object detection model, you can just use the framework in the library instead. So you can actually use what a lot of other smart people has figured out before you. So you're not doing things from scratch. That is one of the big things that I think that we get with this Yolo library here. It is just so easy to use, and you will just save. You will save hours and if not days using the library right here. So I've prepared some code. So if you want to track your camera, then you can use this code right here. You can take it from my GitHub account. It is available there and as public downloadables. So here we have you need to import Ultralytics and also CV2, and you have to add Ultralytics to your requirements file right here. And you have to download these dependencies right here. I'm using virtual environment. That means that my libraries are just right here. And I'm using PyCharm also, so that means that if I did not have these, if I didn't have Ultralytics, then it would actually pop up and say, "Hey, should I run a pip install Ultralytics for you?" And then I'll just say yes, thank you very much. If you're using something else, of course, then you have to go to the folder where you have your pip pip3 exe file right here, and then you have to write pip3 install Ultralytics, and then you would be happy after that. Okay, so after doing that, then you can actually go and then you can use Yolo from your Ultralytics library, and you can just load one of the standard models that are already there, and then you can say, please capture the video. This is from the CV2 library, so that you say, please capture the video, and this is the number right here. So if you have more than one webcam, then you would, of course, have to give the right number right here. Usually it's just 0, so just start with 0 and see what actually happens right here. So, and then you can have this loop right here where you actually go through each video frame one by one, and that means that it will just run in a small window, and then you say, as long as it's open, then it should actually just continue right here. If I can get the image from the camera, it will fail if you try to use something like OBS while you are also running this code right here. That is why I took this screenshot before we got started, because I cannot run it while I'm also recording, because then OBS is actually using the camera. So, but if nothing else is using the camera, then you can actually just do this. I've also seen a lot of examples where people are using them on Raspberry Pis, because on Raspberry Pis you can actually extend your Pi with a webcam, and then you can run the software to do some object detection, like maybe you want to detect when your pets are coming home and then you want to feed them automatically or something like that. It's only imagination that sets the limits right here. Okay, but in this situation right here, if we could get that image, then we are trying to track that frame that we get right there, and then we want to visualize the result in the frame. That means that we're actually saying, please plot the result on the frame right there, and then also show that on top of the image right here. So we have it right there. So that is the window, and here we have the annotated frame, which is which comes from the result. If we press the Q button or the Q key while the Windows is open, then we'll actually quit, and then we'll release the camera and destroy all windows. So quite simple program. Look at this. There's not many lines, especially if you remove the documentation. Then you could actually run really easy. So. Okay, let us try this out, because I have one image right here. I looked for free images of cafeteria, and you can see there's a lot of people right here. There are a lot of items also in this image right here, and we have another program right here which is named Track. Oh, this is from my YouTube channel actually. Okay, let us start with this. Again, we are just loading an official segmentation model, and every time you hear segmentation, do not be scared. It's just because the difference between a categorization model and segmentation model is that segmentation model or object detection, they can actually detect multiple objects in the same picture, while as an old-fashioned categorizer, it will take the whole image and then it will say this is an image of a cat, and even though there was also a dog in the background, and they would just say this is a cat. So yeah, so that is the difference. And of course, object detection is the most usable. Is the most usable purpose, I would say. So here we have, okay, so here I'm actually, in this situation right here, I'm actually typing in, this is one of my videos where I sit and talk. And then you can set, if you set show to true, then you can you can actually follow the tracking. So let us actually try that and see what actually happens. It takes some time to start up, but what it will do is it will take my YouTube video and then it will actually take one frame at a time. You will see like this, and it is very slow. This is from one of the other videos. It's from thread local and JPA entity, and I'm not using the GPU. It will be faster, especially for if you're training. Then I would say then you need to figure out how to use your GPU. I'll make another video on how to do that because it is of course possible. You need to download some NVIDIA drivers and stuff. So we will do that in another video. And then it will be much faster. So, but here, right here, there's one person in the image right here, and of course, we're not going to watch this. We're not going to watch this whole video. It was just to show that this is what it looks like. So, yeah. So let us press Q. Actually, I cannot stop, so we will just stop the program in the background. This will just continue running until the streaming ends. So until the video ends. There's another example I have right here. It's named track.py. Also feel free to take that and use that. And then we have main.py. Let us run this. So now we want to detect the objects in the cafeteria.jpg. Let us see what actually happens there. So what happened there now? Let us see if we look at the output. Okay, so here we have an image 1 out of 1, and then this is the location of my cafeteria, and it's only 640 times 480. 11 persons were detected. Of course, we could go through a loop in Python, and then we could actually get the locations on the picture for each of these persons. And of course, we could also add the frames, the rectangles around these persons, so we can see where they are. That 1 cup has been detected, 5 chairs, 3 dining tables. So it's not bad. It's not bad. And of course, you can always train your model so they get better if you want to. And of course, if you have a specific purpose, let's say you want to detect whether there's a giraffe or not a giraffe in the picture, maybe that is your purpose for some reason, then you can train your model exactly to do that with some YAML files, and I'll make another video where we do that, because then you would actually have like, I think 50 images of giraffes, where you just point out where the giraffes are in the images. It's actually enough to get started at least. But let's let's wait for that for another video. So we have there was one more thing I wanted to do. That was the training part. So if you want to train a model, here's an example of that. So here we are training. We have there's some training data already, and the more epochs you add, the more times it will try to use the same set of images to actually create a good model. And of course, the longer it also takes, I will just run for 1 epoch right here. And then again, we will run the model against the cafeteria when we are done with this again. And this is where we get the performance on the validation set. If you set the epochs too high, then you would actually get an overtrained model, and then the model will work really, really good with the training images, but it will work really poor with images that it has not seen before. So just be careful. Do not set this to 100 or something like that, and then think that that would just solve your problems. Usually it is the quality. If you have garbage in, then you also get garbage out. That's just how it is. Okay, so now it's actually running, and there's a lot of and you can see GPU right now. The GPU is not being used at all. So, but we have there are some lost numbers, and we have some. So that is at some point we should also have some a success rate or something like that. How exact it actually is, but yeah, that is the boring part. That is the part that takes time. The good thing here is that we do not have to invent our own model with own layers like we had to with the TensorFlow examples that I showed you. We can actually just use the models and the techniques that other people have actually have actually proven to be really, really efficient and really good to actually to train your model. So that is the that is it is good that now if we follow the YOLO model and the YOLO way, then you would have an exact way to actually attack each problem that you have, and you could actually solve any problems by just following some guides on the Ultralytics webpage. I think that is also one of the strong sides with this library right here. You have a way ahead. You don't have to invent your own way. And it's very, very easy to get started. Compared to TensorFlow, which is quite it is kind of made for, it's a general purpose tool, of course, and if you're a data scientist, of course, then you're happy. If you're not a data scientist, then you kind of get a bit sad after you do the first tutorials, because you can see that it takes a lot of time and it takes a lot of thinking, where you have to think about how do you want to set your models, which layer should be used, how many neurons per layer should you use, etc., etc., etc. But here you have a way ahead. It's cool. It's awesome. It works. What else is there to say? I think this. Yeah. So this was just to get up and started, and I hope you learned something. And you feel free to take this project. Just start running these. Just right click, and then you just say run on each of these files. Of course, after you have installed the Ultralytics library dependency right there. That was it from me for tonight. I am Yolo. You only look once. It's awesome. It's cool. Try it out. Bye bye. Hope to see you again another day.